Hello everyone and welcome to Origin Connect. This is Vignesh and today we are diving into one of the most fundamental concepts in networking, the OSI model. Even though many of us have heard about this OSI model, it often becomes challenging to connect its layers with real world networking concepts. So, in this video, I am not just going to introduce the OSI model and its 7 layers. I am also going to walk you through a clear and engaging visual example to strengthen your understanding. This is the first video of my channel and also the first episode of the playlist Protocols. I am really excited to start this journey with you. So, without any further delay, let's get started. Imagine this, you are trying to send a message across a huge digital city filled with computers, devices, servers, and endless connections. But here's the twist, none of these devices speak the same language at first. So, how do they understand each other? That's where our hero enters the story, the OSI model. The OSI model is a layered framework for the design of network systems that allow communication between all types of computer systems. Think of it like a perfectly organized 7 floor building where each floor has one specific responsibility. As your message travels, it moves floor by floor. It breaks the communication process into 7 clear layers, and each layer has a specific job. One layer prepares your data, another makes sure it is transmitted, another decides the best route, and finally, other layers ensure it reaches the correct device safely and without errors. And here's an important part of the story. This entire building wasn't created randomly. It was published in 1984 as a networking standard by ISO, all to make sure communication systems around the world could work together smoothly, no matter what device or technology they used. So, the OSI model isn't just a concept, it's the silent architecture that helps every digital message reach exactly where it needs to go. Now that we stepped inside the OSI building, let's open the door to the very first floor, the physical layer, the true foundation of everything. Imagine you are standing at the base of a massive communication tower. This is where every journey of data begins, not as words, not as files, but as tiny electrical signals and pulses of light. The physical layer coordinates the function required to carry a bit stream over a physical medium. In simple terms, if your message was a traveler, the physical layer decides how it steps onto the road, whether it goes as a voltage, light, radio signal, or anything the hardware can carry. But this layer doesn't stop there. It deals with the mechanical and electrical specification of the interface and transmission medium. That means the physical layer worries about things like how much voltage should one represent, what kind of connector should be used, what's the signal strength, the cable type. It's all about the nuts and bolts, literally. And it gets even more detailed. The physical layer is also concerned with the physical characteristics of interface and medium, representation of bits, data rate, synchronization, line configuration, and physical topology. So, whether the data travels as square wave or pulses, whether device sends data one at a time or together, whether the network is arranged like a star or a bus, all of that starts right here. Let's climb one level above the physical layer and enter the second floor of our OSI building, the data link layer, the layer that brings order and reliability to the chaos above. While the physical layer simply sends raw bits as signals, the data link layer steps in like a guardian. It transforms the physical layer, a raw transmission facility, into a reliable link. Its purpose is to take something noisy and unpredictable and make it look clean and dependable. To the network layer above, the data link layer makes the entire physical system appear error free. Now imagine your data traveling across a series of rooms. Each room represents a device or node. The job of this layer is simple but crucial. The data link layer is responsible for moving frames from one hop to the next. It doesn't take your data across the entire network, just the next immediate step, hop by hop, steadily and safely. And behind the scenes, it manages many vital responsibilities like framing, physical addressing, flow control, error control, and access control, all handled right here. It decides how to package the bits into frames, who the frame is meant for, how fast data should move, how to detect and fix errors, and even who gets permission to use the channel at a given time. At the side of your slide, you will notice a diagram with Wi-Fi, Ethernet, switches, and similar components. These are the everyday technologies that depends on the strength and discipline of the data link layer. This layer doesn't just pass data, it protects it, organizes it, and ensures every step of the journey begins correctly. Alright, now let's move up to the third floor of our OSI building, the network layer, the layer where real navigation begins. If the data link layer was guiding your data from one room to the next, the network layer is like the master planner that figures out the entire journey across the city. Because the network layer is responsible for the source to destination delivery of packets, possibly across multiple networks and links. Your data might not travel in a straight line. It might pass through routers, different paths, and even different networks. And this is the layer that chooses the correct routes. To make this possible, it handles two major responsibilities: logical addressing and routing. Logical addressing ensures every device in the world gets a unique recognizable address, and routing decides the best path for the packet, the fastest, safest, or most efficient route to reach its destination. But here's an interesting twist. If two systems are connected to the same link, there is usually no need for a network layer. Why? Because there is no complex path to plan. The data can just travel directly from one system to other. The network layer is essentially the navigator. It sees the whole map, plans the journey, and ensures your packet reaches its destination, no matter how far or complex the route. Now, let us climb up to the fourth floor of our OSI building, the transport layer, the layer where communication becomes personal and precise. Until now, our layers have helped data move across wires, nodes, and networks. But the transport layer shifts the focus. It's no longer about the device or the link, it's about the actual programs running inside those devices. That's why the transport layer is responsible for delivery of a message from one process to another, not just from computer to computer, but from the exact application of the sender's side to the exact application of the receiver's side. It's like delivering a parcel not just to the right house, but directly into the hands of the right person. To make this possible, the transport layer performs several important duties: service point addressing, segmentation and reassembly, connection control, flow control, and error control. It assigns port numbers so message reaches the correct process, breaks large data into small segments, rebuilds them at the destination, manages connections like handshake, and ensures everything runs smoothly. And here's something you may wonder: why do we have flow control and error control here when the data link layer already does that? Well, the answer lies in the scope. The data link layer handles these controls only for the single link, one hop at a time. But the transport layer manages flow and error control end to end across the entire journey, from the sender's application to the receiver's application. Even if data crosses 10 links, 20 routers, or multiple networks, the transport layer ensures the entire message arrives correctly, in order, and without overwhelming the receiver. So while the data link layer protects each step, the transport layer protects the entire journey. This layer is like a reliable courier service, ensuring your message arrives safely, completely, and directly to the right program waiting on the other end. Now we move up to the fifth floor of our OSI building, the session layer, the part of the system that manages the actual conversation between two devices. If the transport layer ensures that messages reach the right process, the session layer takes on the role of dialogue controller. It's like the moderator of a meeting. It establishes, maintains, and synchronizes the interaction among communicating systems. Imagine two computers sitting down for a conversation. The session layer decides who speaks first, who listens, and when each one can resume talking. It keeps the interaction smooth and organized, making sure both sides stay in sync. That's why its core responsibilities are dialogue control and synchronization. Dialogue control handles the when and how long each side communicates, while synchronization creates checkpoints like saving progress during a long file transfer. If something goes wrong, the system can resume from the last checkpoint instead of starting over. The session layer might be quiet and simple, but it's the one ensuring the digital conversation stays clear, coordinated, and uninterrupted. Climbing up to the sixth floor of our OSI building, we enter a layer that acts like a skilled interpreter, the presentation layer. Up to this point, our message has been sent, routed, and organized. But different computer systems don't always speak the same language. So this layer steps in to make sure everything makes sense on both sides. That's why the presentation layer is concerned with the syntax and semantics of the information exchanged between the two systems. Think of it as the translator that ensures what one system sends is exactly what the other system understands. And to do that, it takes care of three key responsibilities: translation, compression, and encryption. Translation converts data from one format to another, like turning a JPG into a bitmap format that the receiving system can understand. Compression shrinks the data to send it faster and more efficiently. And encryption protects the data so that even if someone intercepts it, they can't read it. This is the layer that shapes the data into a form that is meaningful, secure, and optimized, making sure the message remains accurate and understandable from end to end. And finally, we reach the top floor of our OSI building, the application layer, the place where everything becomes visible and usable to us. All the layers below have been working behind the scenes to move, protect, organize, and translate data. But this is the floor where the user, whether a human or a software application, actually interact with the network. That's why the application layer enables the user, whether a human or software, to access the network. It's the layer that provides the interfaces, the windows, and touch points we use every day. This layer also provides user interfaces and support for services, the things we rely on constantly without even realizing their complexity. And these services include some of the most familiar ones: network virtual terminals, mail services, file transfer, directory services, and many other. Whether you are sending an email, downloading a file, looking up a server, or operating a remote session, this is the layer making it happen. The application layer is the final stage of the journey, the point where magic of networking finally meets the user. So, to quickly wrap everything up, the physical layer sends raw bits as signals through cables, light, or radio waves. The data link layer cleans those signals, creates reliable links, and moves frames from one node to the next. The network layer plans the route and delivers packets across multiple networks using logical addressing and routing. The transport layer delivers messages from process to process, handling segmentation, connections, flow control, and end-to-end reliability. The session layer manages the conversation, establishing, maintaining, and synchronizing communication. The presentation layer translates, compresses, and encrypts data so both systems understand each other. And finally, the application layer is where the user or software directly interacts with network services like email, file transfers, and directories. All seven layers work together, transforming a simple message into a smooth, secure, and fully organized communication journey. And now, let's see an example on this entire process in action. Imagine a simple moment. Kushal wants to send a message to his friend Bharat. He types Hi Bharat on his chat application and hits send. But what looks like a simple action on the screen actually triggers a beautifully layered process underneath, a journey through all seven OSI layers. Before we begin, remember that in real life, these layers overlap and work together dynamically. The OSI model is just a conceptual guide that explains what responsibilities must be handled during communication. It's like a blueprint that helps us understand the flow. So, as soon as Kushal hits send, the message begins its downward journey through Kushal's OSI stack. At the application layer, the message is simply user data, readable text prepared by chatting app. Then it moves down into the presentation layer, where it may be formatted, encrypted, or compressed, depending on the app's design. It's still just data, but now prepared and packaged for safe handling. Next, the session layer steps in like a meeting coordinator. It establishes and manages the communication session between Kushal and Bharat's devices, making sure both systems know this conversation is active and synchronized. Once the session is set, the message enters the transport layer. where things become more structured. Here, the message is broken into smaller, manageable segments, each tagged with port numbers so Bharat's device know which application should receive it. Reliable delivery is also ensured at this stage. The segments then move down into the network layer, where each one is wrapped with IP addresses. Now the message becomes a packet, ready to travel across network and potentially multiple paths. After that, the packet enters the data link layer, where it is placed into a frame. This layer adds MAC addresses and error checking information, ensuring each hop along the path knows exactly where the frame should go next. Finally, the frame reaches the physical layer, where everything becomes pure bits, electrical signals, light pulses, or radio waves. This is where Kushal's message physically leaves his device and begins its journey through cables, routers, and wireless signals. Now we shift over to Bharat's side. The bits arrive at Bharat's physical layer and begin their climb upward. The physical layer collects the raw bits, and the data link layer rearranges them back into a frame. It checks the frame's MAC addresses, strips its own headers, and passes the inner packets upwards. At the network layer, Bharat's device examines the IP addresses. Since it matches his device, the layer removes its IP envelope and forwards the segment upward. The transport layer then takes over, reassembling the segment back into complete data and using the port number to deliver the message to the correct application. Bharat's chart app. The session layer keeps the communication synchronized, ensuring that the conversation continue without interruption. The presentation layer then decrypts or decompresses the message if needed and converts it into readable form. And finally, at the very top, the application layer displays the message on Bharat's screen. Bharat looks down and sees instantly, "Hi Bharat." That single message traveled as data, then segments, then packets, then frames, then bits, and climbed all way back up, all in a fraction of seconds. That's the magic of OSI communication journey. That brings us to the end of our OSI journey. If you have followed along till here, you now understand not just what each layer does, but how they work together, making communication look so simple on the surface while performing such a complex dance underneath. I hope this video helped you see networking in a clear and more intuitive way. And trust me, this is just the beginning. The upcoming videos on this channel are going to be amazing. I am fully committed to bringing you the best, most authentic, and easy to understand tech content out there. So if you enjoyed this breakdown, make sure to like the video, subscribe to the channel, and drop a comment below. Thank you so much for watching, and I'll see you in the next one. Until then, keep learning, keep exploring, and stay connected.